Part 4. You will hear a lecture about the design and construction of underground houses. First, you have some time to look at questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Good morning. In our series on sustainable living, we have looked at high-rise timber buildings and floating cities. Today, we are going to look downwards, at the growing field of underground and earth-sheltered housing. Now, when I say underground house, many of you might picture a dark, damp cave or perhaps a military bunker. Historically, that wasn't far from the truth. For thousands of years, humans have used caves primarily for protection, hiding from enemies or escaping harsh weather. However, the modern movement, which really began in the 1970s, is driven by something quite different: the urgent need for energy conservation and a desire to blend architecture seamlessly with the landscape. Let's start by looking at the distinct advantages of building into the earth. The most significant benefit is undoubtedly energy efficiency, and this comes down to a principle called thermal mass. If you stand outside, the air temperature fluctuates wildly between day and night, or summer and winter. However, if you dig just a few meters down, the temperature of the soil is remarkably constant. It stays roughly the same all year round. This means the earth acts as a natural blanket, keeping the house warm in winter and cool in summer, which can reduce reliance on artificial heating by up to 80%. Another major benefit, which is often overlooked, is noise control. Soil is an incredible acoustic barrier. For urban planners, this is a game changer. It makes these houses ideal for plots of land that would otherwise be uninhabitable due to noise pollution, such as areas directly next to a highway or a flight path. Inside an earth-sheltered home, the silence is almost absolute, regardless of the traffic outside. Then there is the safety aspect. We know these structures are safe from high winds and tornadoes, which simply pass over the roof. But you might be surprised to hear that they are also highly resilient during earthquakes. Because the house is buried within the ground rather than sitting on top of it, the structure moves with the earth rather than swaying against it, leading to significantly less structural damage. However, designing these homes is not without its difficulties. The biggest challenge for an architect is the psychological factor. Humans do not like to feel buried. We have a primal fear of being trapped in the dark. Therefore, the manipulation of light is the single most critical design element. You cannot simply rely on artificial bulbs. To make the space feel habitable, architects extensively use skylights. Those are windows cut directly into the roof, as well as light wells and reflective surfaces to bounce natural light deep into the rear rooms. This brings us to the geometry of the house. You can't just dig a hole anywhere. The orientation of the building is vital. In the northern hemisphere, the main glass frontage must face south to maximize solar gain. If you get the angle wrong, the house will be cold and dark, defeating the whole purpose. Psychologically, we also need to consider the view. Research has shown that occupants feel much less anxious if they can see out. Even if the house is mostly buried, maintaining a visual connection to nature, seeing a tree, the sky, or a garden, is essential for mental well-being. It prevents that feeling of claustrophobia. Now, let's move on to the technical construction challenges. The enemy of any underground structure is water. When you bury a wall, you are subjecting it to hydrostatic pressure. If there is heavy rain, the groundwater pushes against the structure with immense force. Consequently, leakage is the most common failure in these buildings. It's not just about damp patches or mold. Water ingress can undermine the foundations. Therefore, drainage systems must be far more robust than in conventional housing. Ventilation is another concern. Because the house is sealed tight by the earth, fresh air doesn't circulate naturally through gaps in the walls. Mechanical ventilation is usually required. This is particularly important for dealing with soil gases. In certain geological areas, a radioactive gas called radon can seep out of the surrounding rock and accumulate inside the home. Modern underground homes must have sensors and vents specifically to handle this. So, what does the future hold? We are seeing a shift. It's not just eccentric individuals building hobbit holes anymore. We are seeing libraries, museums, and data centers going underground. In crowded cities like Tokyo or London, This is driven by a shortage of space. With land prices skyrocketing, the only way to expand is downwards. Finally, the aesthetics are changing. The early designs from the 70s looked very rough and industrial, lots of exposed concrete. Today, architects are focusing on making the designs more appealing to the mainstream market, using warm materials like timber and stone to soften the impact of living below ground.
That is the end of part 4. You now have 1 minute to check your answers to part 4.